I'm Bob Ward from Microsoft, the Principal Architect on the Azure Data Team. Welcome to today's session on SQL Server on Kubernetes at the DPS Virtual Summit. I hope you're enjoying the summit, and I look forward to today when I can join you in person again at a future summit. I just love the energy that I've seen in past DPS summits. So sit back and relax and learn a little about SQL Server on Kubernetes. Now today we are going to be talking about SQL Server on Kubernetes. And before we get started, I'd like to give you a couple little pointers to some resources. aka.ms bobwardms, you can see the deck I'm going to present here today from that resource. And if you'd like to demonstrate or use yourself SQL Server on Kubernetes, you can check out aka.ms SQL workshops. Now in today's presentation, we have three basic areas. We're going to talk a little Kubernetes, make sure we understand kind of what it is, why it's important, why they build it. We're going to look at SQL Server on Kubernetes. And at the very end, we'll give you a little bit of an overview of what does it look like to run production workloads on Kubernetes, including something called Big Data Clusters and Azure Arc. Now let's start with just understanding some Kubernetes. So I want to do a shout out to a couple of members here you see on the screen from the community that spend time on SQL Server and Kubernetes. Certainly follow them because they certainly love talking and presenting about this topic. But you look here, and when you get this deck, you can click on it. A gentleman named Brendan Burns, one of the founders of Kubernetes from Google, who now is a technical fellow at Microsoft and is in charge of our Kubernetes strategy. And I love this because when you click on this link here, when you get the deck, you'll see a series of videos from Brendan about how Kubernetes works. It's a great way to learn the technology. I encourage you after this presentation, get the deck, go check out Brendan on YouTube. We just love the way he presents this as a drawing on this glass technology. So pretty cool stuff to check out. So why Kubernetes and what is this thing? In fact, I have a link here when you get the deck about the origins and histories of Kubernetes, Brendan being a part of that, how they started this Kubernetes project. And Kubernetes means helmsman in Greek, and it's a way to pilot things. So if you think about why they wanted to do this Kubernetes concept, it all started with just scaling applications. You know, you'd like to be able to deploy, manage, and scale an app. Now, how do you do that? You know, you could build your own platform to do that kind of type thing. And in fact, people use the cloud a lot in Azure to do that. But what if you need to do it yourself? Like, how do you have a managed platform to do all sorts of different applications? And so the team at Google that started this project, they knew containers. They had seen this containers technology, but they wanted a way to run containers at scale. It's one thing to run one container, but how do you run a bunch of these things? How do you provide consistency, portability, lightweight, maximum uptime, and faster patching with these containers at scale? And so if you think about it, what Kubernetes is, and I actually pulled this from the Kubernetes website, a system for, look at this, automated deployment, scaling, and management of containers. So you don't just have one, you have a bunch of these things. You need orchestration for a production level. What does orchestration mean? It means I need a way to schedule things. I need to do resource management like memory and CPU. I need high availability in case something goes wrong. I need networking to connect to things that are running as containers. And I need a system to provide storage. You can look at these different topics and you can see and imagine in your mind SQL Server needing all of those things. I need the ability to run SQL Server containers with all that type of orchestration in an automated way through a system. And that's really what Kubernetes is. Now, if you're wondering whether anybody's really using this at production scale, we'll talk about towards the end about a big data cluster or about an Azure Arc system using SQL Server and other types of containers. But Kubernetes has been around for a bit and is used in production workloads. And one of the things that people love about it, it's an open source, consistent platform. In other words, the core of Kubernetes is open source. Now, people have forked off Kubernetes in different types of distributions, and we're going to talk about the players of Kubernetes, but it is open source and it's consistent. And it is industry and production proven. Look at the icons listed on the screen right here. These are companies that are using Kubernetes in production. In fact, my friend Kim Tripp loves playing this game, Pokemon Go. And it surprised her when I told her, hey, by the way, you know, Kim, the entire Pokemon Go game is powered on a Kubernetes platform from this huge multiplayer type of gaming system. So Kubernetes has been around for a while. It is industry and production proven, and it is something that can be used for you as a customer in a production environment. Now, I think it's important to know what is possible out there for Kubernetes. If I wanted to go deploy Kubernetes, where would I go? Who would I talk to? What types of companies are offering Kubernetes, even though it's an open source platform? So first of all, if you just want to use the latest open source, you can use tools called kubeadm, or at a lightweight level, something called minikube, which you can do on your laptop. And that utility will allow you to deploy your own Kubernetes using the latest open source technology on your own environment. And several customers that we have are choosing to do that. Now, there are cloud providers for Kubernetes, and whether it's Azure or Amazon or Google or even Red Hat, including the ability to do it on Red Hat's platform or in Azure itself, these are companies that are providing a fairly managed way of running Kubernetes. We'll talk about in a second what we mean by that. In fact, the demonstrations you're going to see today are going to use Azure Kubernetes Service as a way of deploying and using Kubernetes. So you can go deploy a Kubernetes cluster in a cloud through these providers. Now, you may want to do this on your own in your system. And in fact, if you look here, Red Hat OpenShift is one of the most popular in the world to deploy Kubernetes. With a distribution of Red Hat, they've taken the open source and forked it and made their own Kubernetes environment. They call that OpenShift. Pivotal is out there, Azure Stack, and we're going to talk a little bit at the very end about our technology at Microsoft called Azure Arc that's going to use Kubernetes. And I just picked on Rancher because that's a popular one I've seen from customers use. So these are kind of your players. There could be others that you know about and use, but these are the major ones that I've seen out there, whether you want to use the latest open source, you want to go deploy this in the cloud, or deploy it in a managed fashion on your hardware. Now, using AKS or Azure Kubernetes as an example, what is the overall architecture? What are the pieces of Kubernetes? What is that orchestration thing I talked about? Well, first of all, you have something called a managed node, a master node. And in the case of Azure Kubernetes Service as a managed provider, the master node is managed for you. You don't deploy that. If you did open source on your own, you would be deploying a master node. And it's kind of the brains of everything. You can see the components on here. A scheduler, a controller, an API server, and an etcd database. Now, this API server is kind of important. It's really kind of a genius way of doing things. It is kind of a listener. So the API server will take in requests through REST APIs and then help go do the orchestration of scheduling and things throughout the system. And the master node is the one that's going to control the brains of doing that. And then on each user node, where all the containers are actually run, you have other system components out there that are responsible for orchestrating these containers. In fact, we call these pieces the control plane, and kubelet and kubeproxy are pieces that help make that happen. And you notice the communication here. They're talking to the master, to the scheduler, to the API server to make things work. Now, there's got to be containers running here, so you need a container runtime. And you've probably heard of Docker. Docker is something used in AKS, but there are other runtimes out there as well that are used in other environments. Not always Docker out there, but you need a container runtime that's going to go run the containers, and Kubernetes is going to be the one to orchestrate using the runtime to run containers within the system. So these are the major components you see in any Kubernetes system, but this is kind of what it looks like in Azure Kubernetes Service. Now, you need an architecture diagram. And so to give you the basics of Kubernetes, I thought I'd draw a picture of you of what I see are the basic components. But I give a shout out to the icon at the top right-hand corner of your screen. If you click on that when you get the slide deck, it is a hilarious but very informative video called The Children's Illustrated Guide to Kubernetes. It's like a cartoon of a dad explaining to his daughter what Kubernetes is, and I actually love it. It's really fun to do. Last year at the past summit, a year ago, I actually put up that video up on the screen for everybody to watch as they were walking into the room. Okay, let's first talk about a cluster. A cluster could be a host server, or it could be a virtual machine for you, or it could be a series of virtual machines. Let's think in terms of the fact that a cluster in this case is a host server. It's a host server in Azure that we host for you maybe, or it's in your environment. So let's just talk about first as a cluster. So the first thing is you have a node. We talked about the fact that there's a master node and user nodes. Let's look at these user nodes and what they mean, and think in terms of a node as a logical concept that represents a virtual machine. So in this node, I'm going to have a concept called a pod. A pod is definitely a logical concept. One or more containers could be associated with this pod. And one of the key pieces here is this pod is going to have a private IP address to connect to. Now, you usually want storage. So SQL Server wants storage, right, to be stateful. And so Kubernetes is going to provide interfaces. These providers will provide interfaces to get to disk storage for you to store things. And there's a concept called a storage class, which directly correlates to storage like disks available in the system, like disk types. Now, on top of these disk types is something called a persistent volume. It's a logical concept to give you like disk space that you need from here. And in fact, on top of that could be a persistent volume claim. This is typically what I use with SQL Server. It's like, hey, give me 10 gigabytes of storage space that I need for my databases. So you have storage classes, which are the type, persistent volumes, or you can use this dynamic concept called a claim to get storage for your container living in the pod. Now notice here that the volumes and volume claims span across this entire cluster. You're going to see they're going to span across nodes, and this is a very important concept, as we'll see in a second. So I need to provide connectivity, let's say, to a SQL server running in one of these containers. How do I do that? I got a private IP address, which maybe I can connect to, but I would love to provide a more external address. In fact, I've got an external network that I want to connect into this cluster. Let's say it's in Azure. So there's a concept Kubernetes provides called a load balancer service. There's a concept called a service overall, and a load balancer service is typically done in a cloud provider like Azure. When you say, I want a load balancer service, you get a fixed external IP address that's accessible from external networks outside this cluster. And as it turns out, that external IP address, this load balancer, can be bound to that pod. Why is that significant? Because if that pod changes, somehow that private IP address, I want to connect to that external IP address and make sure that no matter what happens, I always can connect to whatever's running in that pod. You'll see with SQL Server how important that becomes. Now, I might want additional pods and even pods to be able to talk to each other, or containers within pods to talk to each other. So I can create as many pods as resources will allow in my node, and these pods could have multiple containers. You're going to see in the big data cluster scenario and an Azure Arc scenario how we have this multi-container pod type concept. And again, think of this diagram here. Pods can actually have storage in persistent volume claims, which are based on persistent volumes, spanning across the cluster, and the load balancer spans across the cluster as well. Now, I might have more than one node. Now, this can become important when it comes to high availability. Again, if you think of node as a virtual machine, I might want a second one. Because if there's a problem that occurs over here in this one, like the VM goes down, wouldn't it be nice if I had a second one around to help me? Or I just want to load balance out all my containers across my workload. Now, a great example of that is that, and we'll see a little bit later about high availability, but imagine if this pod that has this private IP address has a problem, and we need to spin up another one. We'll talk about how you can declaratively do this, and Kubernetes just handles this automatically. But it's possible that we need to spin up this new pod or this container, and it's even possible that that might happen on a different node. Now, notice the diagrams and the arrows. That pod still talks to the load balancer, which is across the nodes, across the cluster, and it still has access to whatever it's stored in this disk drive for persistent volumes that are across the cluster as well. This is going to, as you're going to see, is a concept of shared storage that can provide a great built-in availability capability for SQL Server. So here's your architecture diagram of Kubernetes. It's my basic way of showing you the major components that make up Kubernetes. And one last call out. You'll notice here it says K8S. If you want to impress your friends and talk Kubernetes, just use the word K8S. And if you wanted to know what that really means, it's a little bit of lazy person's terminology. Kubernetes is K followed by 8 letters followed by S. So people, I get tired of spelling or talking Kubernetes, so they just have a little moniker called K8S. Now, there are other objects that are important from the K8S environment, including a namespace. This is great for scoping your deployments. You can have a development namespace and a production namespace. And I use that namespace concept all the time. Labels are great. Labels are a way of tagging things to organize stuff, for objects to query things and to manage things at a certain level based on a label. And annotations are another way to assign properties to objects to help you kind of use and manage Kubernetes objects based on this annotation, or to associate objects together, like associating a load balancer with a certain pod. Now, you're going to want to do password protection. You're going to see in big data clusters, we are going to do Active Directory authentication. But for basic SQL deployments, you might just want an SA password. So in order to encrypt that, we'll have something called a secret, which is persistent storage to encrypt something like a password. A config-mac, which we won't talk about a lot here in the basic SQL part of it, but it is used in big data clusters, is configuration data you need that's independent of your containers. Think of like a configuration file that you'd like to rely on that's stored somewhere that your container can access. And we talked about load balancing. So if you had your own Kubernetes cluster, you would use something called a node port instead of a load balancer. And then when we talk about high availability, because I talked about the fact that these pods can run across nodes, you have these concepts. You have replica sets, stateful sets, daemon sets, and deployments. We're going to see an example with SQL Server how we're going to use a deployment to have a state we're going to declare to go deploy a pod, including a replica set. And we're going to use a replica set as well, which is really, really nice when it comes to high availability. It gives the ability of Kubernetes to give you built-in availability in case the pod or a node has a problem. Okay, now that you have understanding a little bit of K8s, we talked about clusters, nodes, pods, load balancers, persistent volume claims, replica sets, labels, the different objects that make up Kubernetes. Like, what about SQL Server? What are the basics of deploying and using SQL Server with Kubernetes? So first of all, how do you just use Kubernetes? Well, first of all, no problem. Send REST API requests to the API server. And you're probably going, how the heck do I do that? I'm not a REST programmer. I don't really want to be a REST programmer. That's okay. You can use a program called kubectl. kubectl is open source, cross-platform, works on Linux, Windows, Macs, same syntax everywhere. And what it does is allow you to be a K8s programmer. You're going to use a series of or what does Buck Woody call it? Kubectl commands with parameters to go send API requests to the API server, and that's going to let you do the scheduling and the resource usage and all the stuff that Kubernetes provides behind the scenes. In other words, how do you deploy a containerized application at scale? You're going to use kubectl. There are API calls even above REST APIs you can use as well, but kubectl being the most common tool used to do K8s programming. Now, the thing about kubectl that I love, it's declarative in nature. Some commands, you're just going to run the command line and it does something. In many cases, you're going to apply a YAML file, which looks like a JSON file. And in the YAML file is a protocol for things you need to do or objects you want from Kubernetes. kubectl will take the YAML file, parse it out, send API requests to the API server for whatever you want. And for SQL Server specifically, you're going to do some things. You're going to define storage you need, you're going to define networking like load balancing, and you're going to define high availability you want. We'll see how to do that with a concept called a replica set. And you might need an SA password, so you're going to use a secret to store that SA password. But you want to be smart with Kubernetes, using namespaces to scope out your deployments, using labels, and even using this concept of deployment to organize what you're going to do with Kubernetes is really important. We're going to see in a second what that looks like. And in fact, let's look at a cookbook for the basic deployment of SQL on Kubernetes. So first of all, create a namespace. You don't have to do this. I do not recommend putting anything in the default namespace of Kubernetes. It's just easy to organize what you're doing. Another great advantage. Let's say you're throwing a development concept together to build a new Kubernetes set of pods and a deployment with all these objects. If you create them in a namespace and you just want to tear it down, you can just delete the namespace and they're all torn down automatically for you. Second of all, we'll create a secret for the SA password. kubectl will allow us to do that. And that'll be stored in a persistent way, encrypted in Kubernetes. Next, we're going to create what's called the load balancer that we mentioned earlier. And we're going to use YAML to define what the properties of the load balancer actually are, with a name, ports, etc. And Kubernetes is going to create that public IP address on top of it. Now remember, for your own Kubernetes distributions, not like a cloud provider, this would be a node port. Now we're going to create a persistent volume claim for storage that we need. Again, we're going to use a YAML file to decide what that looks like. And you're going to see how we're going to tie the load balancer and the persistent volume claim together with our SQL deployment. This is where we're going to specify like how much disk space do we want? to use for the storage for like our databases for SQL Server. Step 5, we're going to go create the SQL Server deployment itself. Another YAML file where we're going to declare things like what is the container image for SQL we're going to use. We're going to put labels in here. We're going to tie in the load balancer and the persistent volume claim for our storage. We'll end up mapping that into a folder in the SQL container like var updem as SQL. So you see how that works together when we look at the demonstration. Then this is an asynchronous operation. Remember, we're sending API requests to the API server, so we don't wait for these things. They run and come back to us. So when you create this deployment, it could take a while, right? Depending on how much what's going on your server. In fact, one of the reasons sometimes it takes a while is we have to pull the container images down into the Kubernetes environment to start the container. And a lot of people will pre-pull their container images into Kubernetes to avoid the delay in that step. So checking the status of the deployment done with kubectl is what we're going to do because this is an asynchronous operation. And we're going to look at events. Events help us look at the detailed sequences of things going on in the cluster associated with all the steps we've just done. And then we're going to describe the pod. That's like looking at the details of what's going on behind the pod. And then we're going to do this in a loop. We're going to sit here and just kind of pull this thing and see until it's finished. You might want to look at the logs. For example, the logs from a pod for a SQL Server container happen to be the error log. Other containers and pods could have different types of logs. For SQL, it's the log. So if you have a problem, you might want to check the logs. Maybe there was an issue with starting the SQL container. And then finally, you want to connect and run a query. Well, how do you connect and run a query? You're going to connect to the load balancer. We're going to show an example of how to do that in a very smart way. These are the basic steps to go deploy SQL Server on Kubernetes. Now, I want to kind of take a look at these YAML files a little bit further because when you look at them in a demo, it's going to be kind of blinding a little bit unless you understand the protocol of what's inside them. So let's kind of dive inside the YAMLs a little bit. And by the way, this could all be one step before we get into that. You could take all of this and script it out and make it one big thing. And I've got a little button on here when you get your deck. Click there, and it's going to point you to the tutorial we have in the documentation for all the example steps. But you could also use our demos in our aka.ms SQL workshops for the SQL 19 workshop, where we show you a complete module on the steps for deploying SQL in Kubernetes. Okay, let's look at load balancers and storage and their YAMLs, and this in particular case is using AKS. You notice here it looks kind of like JSON. These labels, colon, and some value have meaning. And if you go look in the documentation for Kubernetes, there's a description for everything of what this looks like. Notice here on the load balancer, you have something called MS SQL Service. That's the name of the load balancer. The app selector MS SQL is important because that's how I'm going to tie together my load balancer with my pod. I'm going to use that same label to tie them together. And notice the ports and protocol here. I've got it's a load balancer type of service that I'm running. Remember, the service is the kind here. But notice the ports. I'm going to map port 31433 for the load balancer to port 1433 for my pod. So what does that mean? When I connect to my load balancer when I'm done deploying SQL, I'm going to connect to port 31433 to be routed and redirected into the SQL container. What about my persistent volume claim? Notice over here, I call it MS SQL-data. I'm going to need that name later to bind it to the SQL pod and the container for its storage. The class is that storage class concept. And for AKS, there's a storage class built into AKS called Manage Premium that maps to Azure Premium Storage. For your Kubernetes provider, you will look up what storage classes you would use. If you're doing it on your own, you'll be defining your own storage classes to point to your disk system. Now, the access mode of read-write once is kind of a little misleading here. That means I can read this data from this persistent volume claim, but only one pod can be writing to it. Obviously, for a SQL server, this is important. Only one pod can be opening up and writing to the SQL server set of databases, including system databases. Notice right here, I'm asking for storage. In this particular case, I'm asking for 8 gigabytes of storage. So think of this as my disk drive. It's my volume that I'm using, right? So when SQL Server binds to this, it gets 8 gig of disk space on Azure Managed Premium Storage. Okay. And by the way, if you want to expand this, you're going to need to customize, do some customizations to get further space from your persistent volume claim. Okay, What about the SQL Server YAML deployment we're going to use? This is a lot longer and a bigger YAML file that's describing here. Number one, I have a name of my deployment, and that's important because I might want to reference that deployment later. For example, I could delete the deployment, which is going to leave the load balancer around and the volume claim around, but everything associated with the deployment would be deleted. So replica 1 is important. This is the replica set concept I talk about. This tells Kubernetes, always keep one of these running, no matter what happens. If the pod goes down, the container crashes, or the node goes down, I want you to manage keeping one of these running at all time. That's important to our built-in high availability concept. I've got my label. This is now going to associate that load balancer with this particular pod. The strategy recreate's interesting. We're not going to cover this today necessarily, but when you want to do an automatic update, you'd like to update SQL Server with a new version of a container, this recreate strategy for a pod is used to actually do that. And then here, I'm going to use an app label called MS SQL. That's a convenient way to manage and query the pod versus having to know this long name that comes out when the pod is actually deployed. Now, in the rest of this YAML file, some interesting things. First of all, I'm going to name the container MS SQL, but here is the image of the container. Now, first of all, you'll notice here this security context FS group. That's something we had to add when we launched SQL 19 because our containers run as non-root. So we need to give permissions for the persistent volume claim, and this FS group allows us to do that. Now, here's the container image. You can be any of our SQL Server supported container images for Ubuntu or Red Hat. In this particular case, I'm using the latest SQL 19 image for Red Hat. Here are environment variables. If you've ever run a SQL container, this should look familiar. I'm going to have a developer edition, I'm going to accept my EULA, and I'm going to use an SA password all fed into this container when it started up. Well, what's the SA password look like? Where is it? Well, it's in that secret we defined, which is encrypted. So I defined my password in clear text before when I built my secret, but it's encrypted, now part of the secret, and I just specify the name of the secret, so that is now passed into the container. The volume mount's important. If you'll notice these two pieces right here, the persistent volume claim was called MS SQL data. That's mapped into a volume name called MS SQL DB, you see down here at the bottom. But that is mapped into a mount point called var MS SQL. Well, what does this even mean? What it means is that when that container starts up, SQL Server Linux containers store their databases by default in var MS SQL. So when they store it in var MS SQL, really it's being stored in the persistent volume claim that we defined earlier, which in this case is an Azure storage. Why is that important? Well, if the pod goes down, which means the container goes down, I want to keep my databases around. And remember that high availability story? This will become very important. So it's a way to have persistent storage for container data, which in the case of SQL Server are databases. Now that's a look at the steps for doing SQL Server deployment and a look at the YAML files. Let's actually go see the example, and I'm going to use Azure Kubernetes Service for a demonstration. Now to demonstrate SQL Server on Kubernetes, I'm going to use Azure Kubernetes Service that I've deployed. I've already actually deployed the Azure Kubernetes Service. You can do that from the portal. You can do that through as CLIs. I've already got that service deployed in Azure. And since I'm in Azure, I can use the Azure Cloud Shell. I love the Azure Cloud Shell. I've never used it before. Comes with a built-in bash shell. Comes with all the tools and utilities I need to do various things, including kubectl. So if you look at my screen right here, I've got saved in Azure Cloud Shell storage a set of scripts to go automate how to go deploy SQL Server in Kubernetes. And if you go look at ak.ms SQL workshops and you look at the SQL 19 workshop, a lot of these steps are the same. So you can just go run all these things yourself by looking at GitHub and looking at our steps. But let's take a look at a couple. Now, some of these things I've pre-done already because they take a little time. So the first thing I want to show you is I want to create that namespace. So how does it look like when I've created that namespace? It looks like this. kubectl, create namespace, name. Pretty easy, right? And again, when I want to like destroy everything I've done, I can just delete the namespace and all the objects underneath that namespace are deleted. So the second thing I want to do is I'm going to set context to my namespace. And these are kubectl commands to use context so that anything I do by default is under the MS SQL namespace. Otherwise, I'd have to specify that namespace with every kubectl command I run. The next step here, step 3, is to create the load balancer. You'll notice here, In the first set of kubectl commands, I didn't have any YAML files. I just created a command with some parameters and it did an operation. Here, I'm going to use the apply command with a file, called a YAML file, to do a declarative program to go build this load balancer. Well, what does the YAML file look like? Let's go look at it. So SQL load balancer YAML. You'll notice down here, it's just like I showed you on the slide before, called MS SQL service. My ports all lined up. And in fact, if I run this command right now, kubectl get all, I can see, kubectl get all, I can see here my load balancer has been deployed. And you'll notice here, there's an external IP address associated with it. And here it's mapping that port 31433. So when I'm going to connect to my SQL server, I'm going to connect to that external IP address listed right there. So let's go back up here to the top and let's look at step 4. Step 4 being creating the secret. This is my MS SQL SA password. So I haven't done this. I cleaned up this before. So I'm going to go ahead and run this step. And I'll just run it by running this script. Step 4, create secret. It's all finished. That was very quick. Doing a secret is like a very fast operation. Well, what does step 5 look like? Step 5 is to create storage. I've got another YAML file to look at. So let's take a look at storage.yaml. You can call these names whatever you want. There's a protocol though for the YAML file. And here's a quick tip. Don't build these yourself. Go take an example from someone else, take an example from me, and modify it accordingly. So you'll notice here, it's exactly like I showed you on the screen. I've called it MS SQL data. I'm going to use Azure Managed Premium Storage right here, and I need 8 gig of space. So let's go ahead and create that storage. I've already done my secret. So step 5 is creating the storage. This takes a little longer than before, but it's all done. At this point, it's all finished. So let's clear back here and go to step 6. What is step 6? Step 6 is actually the deployment of SQL 19. And what does that look like? Well, there's that big YAML file that we looked at. So I'm going to use an editor here within Azure Cloud Shell to show you what this looks like versus just trying to dump it out. So I'm going to use my editor. I just love this tool. And I'm going to come through here and I'm going to find the SQL 19 deployment YAML. Now notice here I get kind of like a GUI editor to use and edit files within the Cloud Shell. And I still got my shell underneath here. So this looks a lot like, if you remember before, this looks a lot like what we showed you. Here's the name of my deployment. Here's my replica set. I want one of these to run at all time. I've got my labels to associate the load balancer with this. I've got my strategy of recreate. Again, we won't cover that today, but that's how you get a new pod created with a new container if you want to update a version of SQL Server. Sorry about that. And here, that FS group we talked about, that's for because I have a non-root. Here's my container image. Here are the parameters that I need, including the secret, EULA, developer, and SA password. Let's keep scrolling down here. And then here's my volume information. If you remember before, I've got a persistent volume claim, and I'm going to name a volume called MS SQL DB to associate with that. And then that volume is going to mount to this directory. And again, anytime a database is created now in the SQL container image in this directory, it will be automatically stored in my persistent volume. And remember, that is across the entire cluster. No matter where this node, where this pod lives, across any node, I've got 2 nodes in my cluster here. That database is always persisted and stays around. It's a key aspect to availability. Okay, so let's go ahead and we're going to exit out of our editor here. And we're going to go ahead and deploy the SQL container. Now remember, this is asynchronous. So like, what do you do now? How do you know if it's finished? So what does step 7 do? Step 7 is going to get various events. These are specific events that are occurring within the cluster. It's like a log of events in Kubernetes. And it shows you some of the stuff that's already happening. Building persistent volume claims, creating my deployment, which is part of my pod I'm doing. And notice it's building up a replica set, which is that, remember, I'm keeping one of those around at all times. Well, step 8 here, and you can do various commands to keep monitoring the state here, but step 8 is to describe the pod. This is details behind the scenes of what's in this pod, including what containers are in it. This is important if you have pods with multiple containers to find out what containers exist within the pod I'm building. And you notice down here, there's events specific to that pod. So let's clear here and go to step 9. Step 9 is a get all command. What is a get all command? I'm going to show you this command earlier because I use this all the time. This is running kubectl get all. So within my current namespace, get me all the objects that are deployed as part of my namespace. Notice here, this is the name of the pod that's deployed. It's at a ready state and it's running. What does that mean? Running means SQL Server is up and running because that's the container running in here. I should be able to connect to it. Here's my load balancer. Here's that external IP address. And then notice right here, this is my replica set that I built. I have one of them, current, one is ready. If there's some problem where SQL Server can't be run, that replica set would say 0. So according to what I'm seeing here, SQL Server should be up and running. I should be able to connect to it, running inside Kubernetes. So what does step 10 look like? Step 10 is to get logs. Well, I want to see logs associated with this pod, which are the SQL Server error logs. How am I going to do that? Well, let's look at the script for a second. If you look here, this is where I'm using that label concept because the logs are associated with containers in pods, but I don't want to put this full pod name. This is the name of my pod right here, and I don't want to remember that every time. So I can use this label called MS SQL. Notice it says app equals MS SQL and get the last 100,000 lines of the log. So anything associated with that label that would dump out. In this case, it's just one pod. So I'll do get log, and I think that looks familiar. Does that not look like an error log for SQL Server? So an easy way for me to go get the error logs involved with SQL. So what does step 11 look like? Step 11 is to query it. Well, how are we going to do that? We need to connect to that load balancer. Great trick that I've learned from folks in the community and experts about how to do this dynamically. I don't want to put in that IP address, but I do want to hard code the port number because I specified that. This is going to use a kubectl command to use JSON to parse out the external IP address of the load balancer. Don't try to memorize and look at all the details, just borrow it and then use it. You'll notice here, I can use SQL command now to connect using that password with SA to the external IP load balancer address based on that variable now, to that port number and run that version. You may be asking yourself here, well, did you install SQL command? The Azure Cloud Shell comes in again. SQL command is built into the Azure Cloud Shell, so I don't have to install anything. I'm just going to go run this, and it's going to connect to this existing SQL server and show me, here we go, here's SQL 19 running on a Red Hat Linux container, and I've connected into SQL Server. Pretty cool stuff. Well, now that you've seen the basic deployment operations for SQL and Kubernetes, it was pretty simple, right? SQL's up and running now. I can connect to it, do various things. In the examples I have in the workshops, it even shows you how to copy in a database backup and restore it because you're just copying files into a container running in SQL Server in a pod. But we talked about built-in availability, and I thought I'd explain a little bit more what I mean by that. I call this basic availability. In fact, notice on the screen, built-in HA with no clustering required. Wouldn't that be nice? Now, if you remember this concept that we had, we deployed a SQL Server pod on a node. In this particular case, think of this example as having 3 nodes. Here's my container SQL Server running in my pod, connected to that persistent volume claim. Remember, that's where the databases are stored, and with a load balancer service. Remember, that load balancer service runs across anything in the cluster, but that's redirected into the pod running SQL Server. And in fact, my application, in this case SQL command, is connected to that load balancer. Now, what about various crash scenarios or problem scenarios, and why do I call this basic availability? Well, first of all, notice here that the replica set I defined spans the cluster across the nodes. I only had one in the replica set, but what does that say? It says if that container in that pod has a problem, make sure you spin up another one. So for example, if the container dies, which SQL crashes or something, Kubernetes will just spin up a container in that same pod, typically on that same node. Well, that's pretty cool. It's pretty easy. You just retry your application through the load balancer, you're up and running. Remember, the databases are in your shared storage, so nothing matters. What if the pod has a problem? Well, depending on what other pods are running in this node, Kubernetes can decide to spin up automatically, because you said you want a replica set of 1, another pod on the same node, running that SQL container. Remember, the databases are still intact because I'm just pointing to that persistent volume claim. The load balancer is redirected to this pod, a new private IP address. Everything is good. What about if the node has a problem, like the VM behind the node goes down? No problem. Kubernetes can say, I'll spin up another pod on a different available node, and because it's a replica set of 1, my load balancer is redirected, pointing to my persistent volume claim. This is the fundamentals of built-in availability. It kind of feels like a failover cluster instance, doesn't it? Shared storage with SQL Server automatically deployed through a replica set, built-in availability. Let's take a look at a demonstration of how that built-in basic availability works based on the demo I did earlier. Okay, back to the Azure Cloud Shell where I had my deployment earlier. Let me get things cleared. And if you go back and look again at all the different scripts I did, we finished with step 11, which was to query the SQL Server container in the pod. What is step 12? Step 12 says crash SQL. Well, how do you crash SQL? No problem. Just use that same SQL command and run a shutdown with no wait. That's a way to simulate shutting down SQL. And what's going to happen when I do that? Well, first of all, let's go back here. Let's look at kubectl get pods. If I run that, here's my pod, but look at this. I'm going to do -o wide. That's going to give me that private IP address of the pod that's running. So let's go run step 12. Just remember, it's 244.1.7, right? So let's go step 12, crash SQL. Okay, it's like a shutdown with no wait. Step 13 says connect to it again. And that's using that same load balancer. I come back, I connect, I'm up and running. That's kind of what you expected. SQL shuts down, it's a replica set of 1, and since the container went down, Kubernetes restarted it. Okay, let's clear and go again. Remember that IP address here, 244.1.7. So what does step 14 say? Step 14 says simulate a pod failure. Well, how do I do that? Well, I could delete the pod based on this application label. I don't want to remember the pod name. Remember, I used the label in this particular case. And if I delete the pod, we'll see what happens here. So let's go delete the pod. It's kind of dangerous, right? We're doing this. Whoop, there's the pod name based on this deployment that's being deleted. And I'm going to rerun that command to look at the private IP address. Because here's what I expect to happen. I expect Kubernetes to restart my pod probably on the same node. So I'm going to run here. I'm going to go back and look at my command. And sure enough, the pod is already up and running with the container with a different private IP address. Well, that's a problem, except my load balancer is redirected to that. So step 15 says, just do the same thing. Well, first of all, I guess here's the pods I just showed you. That's the step 15. Step 16 says, run the query again. Let's just dump that out so we're just clear about what we're doing here. It's the same query as before. The same load balancer address is now directed to that private IP address. No problem. Run step 16, and I'm good to go. Now, if you really want to go further, we won't do this here today, but 17 is draining a node. That's a little dangerous. You have to know the name of the actual node here, but this is a command. Let me clear this and show this to you again. So if you really want to get bold here and play with like shutting down a node, you can drain a node and force it to drain everything. And if you've got multiple nodes on your cluster, Kubernetes, because we have a replica set of 1, would take my pod and go deploy that on a different node. It's going to take a little longer to do that probably because that container image for SQL is not pulled there. But this is an example of basic high availability using Kubernetes, using replica sets, and how SQL works with that because we have load balancers and persistent volume. So you've seen a demonstration of how to deploy SQL Server on Kubernetes and some of the basic high availability capabilities of K8s. So a couple of just points you should be aware of for SQL Server and Kubernetes. First of all, you're going to need some expertise. If you want to do this in production, you're going to need somebody who knows Kubernetes to make this work for you. Even in the managed scenarios, it's something that's going to take some people to get networking and storage and some of those things correctly. So one thing to also keep in mind here is eviction thresholds for memory and disks pressure. SQL Server doesn't understand the eviction thresholds for Kubernetes, which may decide to move your pod somewhere else because it's low on memory. We can't detect those scenarios because for us, we have our own detection algorithms for, say, the amount of memory left in a VM, which may be different than Kubernetes. So take a look at those and make sure you understand how to configure SQL accordingly. And then, can you use this stuff in production? You can. And we're going to look at a second about some examples of doing that at scale. But just keep a couple things in mind. SQL Server containers can perform just the same as SQL Server on Linux, provided that the Kubernetes environment is powered correctly with networking and storage. So basic authentication only today, except for big data clusters, which we're going to talk about. But these are some thoughts about as you're thinking about, can Kubernetes be the right environment for me, for my applications, and for SQL Server itself? So you've seen the basics of SQL and Kubernetes. What about some scaled application examples? In SQL 19, we introduced a concept called a big data cluster. You're looking at the architecture of it. It looks mind-boggling. It is a combination of pods running SQL servers and other components for big data like HDFS and Spark, and various pieces, including built-in availability groups and Active Directory authentication. It's quite amazing. It's an analytic platform built on Kubernetes. In fact, let me just show you some of the numbers behind this. If you were kind of wondering, like, what is in this thing? Well, take a look at this. And these numbers may be slightly off from when I built this slide originally when we launched. You have several pods, 55 plus containers. We use all these concepts: load balancers, replica sets, stateful sets, and we use labels to denote things like planes and roles. And as part of this solution, we're going to do some built-in availability pieces more than Kubernetes. We're going to have built-in availability groups as part of this solution, using a concept called operators and even things called config maps. So big data clusters is an amazing example of running SQL Server containers in production. We have customers like Balzano doing it today. But look at this. This is really the true example of Kubernetes. Containers at scale, 55 plus containers all running in a single solution. Now, we just announced last year the concept called Azure Arc Data Services, or Azure Arc Enabled Data Services, and we'll continue to iterate on this technology. This is bringing the power of Azure to you using Kubernetes. We're going to use some of those concepts in big data clusters like controllers and so forth, but this time what we're doing is exposing basic database services like Postgres and Azure SQL Managed Instance in a Kubernetes environment, giving you that feel of platform as a service with simplified deployment, migration, and manageability, and connecting you to the cloud, connecting you through an Azure environment. Let's just take a brief example of what deployments look like for both a big data cluster and Azure Arc enabled data services. I want to show you a quick example of what a SQL Server big data cluster looks like from a Kubernetes perspective. Remember that command kubectl? Here I'm connecting to that big data cluster. It's running on AKS, and I'm getting all the pods that are listed out. Remember we had like one pod for SQL? Look at all the pods that make up this solution. And you can see here these numbers 2 and 2 and 3 and 3. Those are the number of containers that exist within each pod. So the master pod is where the master instance is. There's 3 of them because of the built-in availability group. There's the storage pool, the data pool, and all these other things that make up and power the solution. Another way of viewing this is with Azure Data Studio and using a Kubernetes extension. I'm doing that here. I'm connected to that Kubernetes cluster, which is running Big Data Cluster, and I'm seeing all the pods. And I can take a look at something like the storage pool, which is a stateful set. And I can go connect and say, let me do a terminal connection into a container there. If I click here, here are the containers listed in that storage pool. There's a SQL server, which really don't access directly, but notice Hadoop is running here. So I could pick on the SQL Server container, and all of a sudden in Azure Data Studio, I'm inside taking a look here at an actual container, and you can see SQL Server's running as a process inside this container, of course. That is part of the solution. Just an example of containers at scale using SQL Server big data clusters. Now, this is a very Kubernetes look at this. If you want to go look at big data clusters in an application way and how to use it, check out our workshop on ak.ms SQL workshops. So that was a big data cluster from a Kubernetes perspective. What about Azure Arc Enabled Data Services? Well, I told you before in the diagram that it wasn't about a big data solution with SQL Server. It's more about database services, such as Postgres and Managed Instance. Well, here's a Kubernetes command against an Azure Arc Enabled Data Services cluster that I've installed in Kubernetes with Azure Kubernetes Service. And you'll know here that kubectl for get pods is showing me some of these pods look a little familiar and similar to big data cluster, but here's one difference here. This right here, this particular pod is a managed instance pod. And how do I know that? Well, Azure Arc Enabled Data Services comes with a command called asData. Think of this as talking to a controller, kind of our API server for Azure Arc. And asData is a tool that's going to talk to that controller to do various operations within the cluster. So I can kind of click here and type in asData and get a list of managed instances that are deployed in this cluster. Here's my endpoint to my SQL, and here is Management Studio connecting to that SQL. In fact, I was able to actually restore a database from Azure Storage into my managed instance. So Azure Arc Enabled Data Services, an example of Kubernetes with containers at scale, and we're bringing the power of Azure where you need it, including an Azure SQL Managed Instance. Well, hey, as we wrap it up today, there's a few other points I think you should know about SQL Server and Kubernetes in general. So first of all, most of the time you may have seen me, and I use demonstrations today with Azure Kubernetes Service using Docker as a container runtime for AKS. But it's not just about Docker. There are other runtime engines out there, including Containerd and CRO, which are used in other Kubernetes environments. So if you're used to using Docker, that's fine, but just note that containers are a general concept and Docker is just one aspect of that. So there are the container engines that you could see out there. Another aspect is Helm. Helm charts being an interesting experience that is available now in many Kubernetes distributions for kind of a more package installation experience. And there are Helm charts out there available for SQL Server that the community have built. And again, the idea being you're used to something like a yum install package environment or apt-get for Ubuntu. For Kubernetes, you can also do a package installation experience using a concept called Helm charts. So check out Helm charts. You can look up many aspects of that. And then think about today in your environment. You may be running a farm of SQL servers and virtual machines, and now maybe Kubernetes could be your new SQL farm with a series of SQL Server pods, taking advantage of the built-in high availability capabilities of Kubernetes and integrating that with things we've talked about today with SQL Server. And then one last point, if you're thinking about using Kubernetes, getting storage, getting networking, and the whole cluster management aspect of Kubernetes is absolutely essential. Some Kubernetes providers like AKS do some management for you, kind of a managed experience. Red Hat OpenShift, another example. But if you're going to deploy Kubernetes yourself, just like you've had to, in some cases, learn operating system concepts with SQL Server on Windows or Linux, or perhaps work with an infrastructure group in your organization, you need to do the same thing for Kubernetes. So just don't assume that it is a full platform as a service operation, like maybe say Azure SQL Database. So getting these concepts are correct, because if you don't have these right, then your SQL experience may not be the best. So just a few tips and points I think you should know as we conclude today about running SQL Server on Kubernetes. Well, it was a lot to consume, but you learned the fundamentals of Kubernetes, the basics of deploying SQL on Kubernetes, and you learn about applications of Kubernetes with big data clusters and Azure Arc-enabled data services. So before you go, take a look at these resources. The slide deck is here. These are the videos that I've talked about in the talk about the Illustrated Children's Guide, Brendan Burns videos. I highly recommend those. Our tutorial for basic deployment. And again, I can't emphasize AK.MS SQL workshops. There's a full workshop on big data clusters. There's a workshop specifically just on basic SQL deployment on Kubernetes. And what's without a shameless plug of a book? I wrote a book on SQL 19 last year. It includes an entire chapter of Kubernetes and SQL Server. I hope you enjoyed this presentation today where you learned more about running SQL Server on Kubernetes.